Alright, hello everyone. Welcome back for some more game audio live streaming. See if I once again can get all of my stuff set up properly here. And we can get started. Bring down the volume of the music a little bit like that. All right. Let's see where we left off last time. So I actually streamed yesterday. We actually looked at the oh, this is the wrong project. Let's open the correct one. So here we have the dev project, and if we bring the actually let's mute the music for a little bit. So we can play some music through this event here in Timbre. So if you're completely new to this is my custom game audio authoring solution. Maybe let's bring the audio down a little bit. Let me know if these audio levels are good or if they are too loud. I think I actually had a little bit of uneven levels yesterday in the stream. So the desktop audio was like considerably lower. Also, actually, my speech, my microphone was considerably lower than the rest of the audio, and so I'm trying to get the mix a bit better for today's stream. But let me know if any of these levels are sort of unbalanced. Anyway, we have this this piece of music playing here. We can actually just restart this thing. And what we did yesterday was something called seek speed in these parameters. So we start messing around with the speed here, for example. We can see that the speed, the playback speed of this is sort of adjusted smoothly. Even if we whack this thing up and down, that orange line here actually specifies where it is. And so this ascending and descending parameter here, or field of the parameter, specifies how quickly it can rise or ascend and descend. Hey Tutu. And yeah, I did a little bit of work on that yesterday, so now the UI is sort of makes sense. So now if you stop it, it doesn't show where those things are anymore, which was a little bit confusing. And also, like, if you create a new parameter here, it just shows you none instead of 0, which wasn't necessarily all that clear what that meant. But anyway, now we can adjust these parameters here very nicely and smoothly, and that should help out with all kinds of things. Today we're going to expose noise generators to this system, and thus the title of the stream. So noise is something that we can generate here in SoLoud. So this is the audio library that I'm using. And SoLoud has built-in noise generators. I haven't used these at all. I'm going into this basically completely blind. But I do know that I will want to be able to generate noise. Noise is useful for all kinds of audio effects. And this looks sort of simple enough that maybe we can get like a basic system going on stream today. Let's hope that is the case. So this seems to come in like a few different versions. I can try to make this a little larger for you guys. So we have a sort of simpler API where you can give it white, pink, brownish, or bluish. I don't know why they're called brownish or bluish instead of brown and blue, but I'm guessing these are sort of approximations of brown and blue noise. I think white and pink are typically the ones that you use as basis for all kinds of nice effects and things like that. But maybe brownish and bluish can be useful for things as well. Then you have a more complex API, which is like set octave scale. And you get to set, I think this is like 10 different... Oh yeah, the noise generator has 10 octaves. And as far as I know, this set type is just basically like calling this with various values. So you can get very sort of technical and complicated with this stuff, or you can just remain kind of simple and just tell it, hey, I want white or pink or whatever, and we're going to go with that today. And then I don't even technically really know what to input here. I would have to mess around with that to figure out, but maybe we can later on make like an advanced noise node which exposes that stuff. But anyway, what I was thinking is that we would create a new kind of node. You can see here that this takes an audio source as input. So this green connection here, this is an audio source. And an audio source is something that you can play directly with a play audio node in Timbre. You can convert things to an audio source. Currently, we only have wave asset references. So there are a few different ways that you can do this. You can get the asset ref from this and convert it to an audio source, and that way you can have just one of these nodes. Basically one wave asset, one, in this case, MP3 file that gets embedded into the data, even though you can technically specify the runtime format of it. But yeah, I digress. You can use it as just an audio source directly, or as an asset ref, and then this asset ref can also be turned into an audio source. And this allows you to add filters. There are 4 filter slots here. You can see that you also have 4 filter slots over here, so you can just set them on the thing directly. But if for some reason you want to have like an unfiltered version of this guy and also a filtered version, you can just use the asset ref here. Regardless, the thing that this play audio node wants is going to be an audio source in every case. And so what we want to do here is make a new node type, which would be like a noise generator, which has as its output an audio source, and we can just play that, plug that into the play audio node, and it will basically keep playing the noise forever and ever. There's no beginning or end to the noise. It's just generated. Is that node network still the WinForms thing? Yes, it is. It is still WinForms. Yeah. Yep. Still the same thing. So it is technically like let's have a look. It's called ST Node Editor. if I can find the thing. Yes, this one. This is the basis for the whole system. It looks a little different. I made some changes to this. You can actually find my fork of this as well. You can see this. This looks a little simpler. This is actually just a screenshot of Timbre, as you can see. This is my fork of the SD node editor. It is both ahead of and behind the main one. But yeah, I made some changes to this and some improvements, and it works more like I want it to. You're free to use this if you want to mess around with this stuff. Anyway, let's have a look at the SoLoud API. So SoLoud is a C++ library. It's basically essentially like a collection of C++ classes. You can do with them whatever you want. You can build them as a DLL and load that as a C API if you want to use it that way. I just use it as a C++ collection of classes, basically. So the code is actually incorporated into the Timbre code. You can see the Timbre project is here. This is the Timbre runtime. The Timbre runtime has a bunch of files and classes here that are sort of considered to be sort of like the Timbre runtime core. Right? You have a Timbre filter, for example. And we have a Timbre event instance. Then we have a collection of nodes. These are all the audio nodes and sort of audio related nodes in the system. And then we also have the whole SoLoud library. So this is not code written by me, actually. This is the SoLoud source code just brought into the whole thing, so that we can just compile it as part of the Timbre static library. And this guy has, I think it's an audio source, probably. Yes, SoLoud noise. So this is, as you can see, it's very simple. Here we see the set type. If we click set type, I think it probably, yeah, it just has a switch case and then it sets the octave scales according to the type. So basically we want a node that encapsulates one of these noise guys. These are already audio sources. They create noise instances as needed. And SoLoud takes care of doing the instantiation based on whatever it needs. So we basically just need to wrap this noise class inside a node so that we can represent it here in this node graph. So it should be as simple as basically creating a new node in Timbre, and that should be it basically. So let's start by doing that. And we need to create a new node. You need to create 3 classes, 2 C# classes, and well, the C++ side is technically not a class. It's just a header and a CPP file. Really, you don't need to, like, a node at runtime in its most basic form is basically just a function. You can have if I have a node that has like 1 input and 1 output, it can be just a function that reads the input and outputs something else. But most of the nodes are a little bit more tricky, more complicated. So let's have a look here. We have the nodes here in the Timbre project. So this is like the base library for Timbre, and then we also have the Timbre editor. And when you create a node, you want a node to actually be sort of the representation as part of the data. So to process Timbre data, you don't necessarily need to start the editor, right? The editor is just like a view into the Timbre data. But we want to have a node that represents the actual data. So you could have like a command line converter that converts Timbre data, for example. And here we'll want to have a noise, what do we call it? Noise generator, or is it just noise node? Maybe we'll just call it noise node. Something like that. And then if we want to have a separate node for the advanced stuff, we can call it advanced noise node or something like that. Or maybe we'll like just have like a toggle that makes this into an advanced sort of thing. And we can look at this wave asset node as a sort of as a reference here, because this thing will output a lot of the same things actually as this wave asset node. So you can see it's not super large. It has some input pins, it has some output pins, and then this is just like basically the inputs need to be satisfied. If we don't override this thing, then they will only be satisfied if all of the input pins are connected. We don't need it for most pins, so you can just set to overrun and always return true. So you can just leave some of those pins unconnected if you want to. Then this guy has an asset GUID. This is not something that we really need for this. One reason why I actually want this node, this noise node here is because currently I actually use noise just by importing some wave files, and it would be really nice if I could just generate that noise on the fly. It's not like computationally very expensive anyway. So we don't really need any GUIDs pointing anywhere else. And then we need to have a convert function here, convert to Sprinter. So Sprinter is that's the runtime library that runs those node graphs, right? So we just need to convert it into Sprinter form so that the game or the audio editor can actually run it. So let's copy this entire guy over. You can see that it also derives from Sprinter data node, Sprinter data node base. Let's just call it wave. Instead of wave asset node, we call it noise node. This needs to be, all right, we need some usings here as well. Probably. So this needs to be the node conversion for the noise node, and we need to input the noise node there. And then we actually probably want to have some properties. So we can see here, start writing node properties. We can put stuff to the stream. So basically I was thinking that we would take this parameter type here and actually make like an enum for this, so that we can make a drop down selection box in the node graph for which kind of noise we actually want to generate. And that would also be a property here. Advanced settings visible, that's actually something that I might want to have later. So basically what that does is, if you actually run this thing, I'm not necessarily planning on having that immediately, but maybe it can be just as easy to do immediately. So wave asset has this drop down here. These are called the advanced settings. If they are visible, then we add a bunch of new input pins here and actually a few output pins as well. So we could, at least like in theory, because this is an audio source, both in the timbre sense and the so loud sense, it should, at least in theory, support filters just straight away. So you could actually generate noise and then have a filter on top of that if you wanted to. And that could be kind of interesting. Actually, that's probably something that we'll want to do. So maybe we'll actually implement at least these filter pins. Length and asset ref, these don't really make any sense for generated noise. Like the noise is infinitely long. Like it just keeps going and going essentially. So length doesn't make any sense, and of course we don't have any asset either. Yeah, so let's just keep this around actually. But instead of this asset GUID, what we will want to have here is a noise type. Maybe I'll actually want to put it just in the timbre types here. Do I? Maybe I don't want that. So previously we did the reverb filter node, and it has a filter type enum like this, just straight in the node. Let's just do the same thing here. So we'll have a noise type, and the noise types were white, pink, and let's just call it what it is here. So brownish and bluish. Is that how we type bluish? I think so. Brownish and bluish. At least we're not misrepresenting any of the actual data there and calling it brown or blue if it is in fact not brown or blue. So it can default to white noise. What do we call this? Like it can be type. That's fine. That's fine. So the filter nodes are there. We also have the output node, which is in parentheses currently here. Parentheses means that it's this out value is not written. It's just a pin without any label essentially, which is kind of nice in some sense, because this is a noise node. It should be somewhat obvious that what it produces is noise, right? So don't really need to label it as noise. It is just the output. Asset ID, we don't need any of that. This is just used by the wave asset node to actually, well, mark asset used. This basically makes it include the asset in the data. That means we don't need the builder context. We can keep it around if we want it. So we add a node with the registration name. We'll get to that in a little bit. Write the node property data. This is where we will want to write the type, and we can just copy paste it from here. So we write the data as a uint, unsigned integer, to the properties stream, because this node, the noise type of this node is not provided by an input pin. It is actual data that is carried around by this node. So it needs to be written somewhere for the runtime to be able to actually read that stuff. Finish writing node properties, and then we can just call add all pins of node, and it just goes in and adds all of those things. So this should be everything we need for the data side, and now we just need the UI side. So I'm just gonna basically move this reverb stuff here to the side so that I can refer to that. And if the data node is put here in the Timbre project, then the UI side, which needs to be sort of matched to this data side, it is put in the Timbre editor project. So let's create a new class here, and the name doesn't really matter, but I typically use the same name for both the UI and the data side. So basically what that means is that when the audio editor loads a Timbre project and it encounters nodes in that data, and it basically wants to show the node graph to the user, if it encounters a noise node, it needs to somehow visually represent that, and it does that with a UI version of the noise node. And the UI version of the noise node looks a little similar but also a little different. So this is just the reverb filter node, and I copy pasted that because it actually uses many of the same things. Again, we'll want some using statements there. So noise node, and yeah, reverb filter So noise provides a noise, provides a generated noise audio source. Noiser, like so. And you can do it. You can set it to like auto size itself, but because this node can actually be resized whether or not you actually open up those advanced settings or not. You can't really use auto size for this, so we have to size it ourselves. And we don't need any of these options. So ST node editor. So that's the WinForms library that we looked at previously. It calls those pins options. So that's why they're called input options here. I typically call them pins. That's just what I've always heard people use when they refer to input and output sort of ports in node graphs. So I call them pins, but ST node editor calls them options, so that's why it's called input options and output options. And this guy actually derives now from one of those ST node editors classes. So we can look at UI node base. UI node base derives from ST node, and this is part of that library that we looked at. So let's get rid of the input options, and again we have one option here, which is the output. So it should be called parentheses out, and it should be of type audio source. This false here and true here, this specifies whether or not this is a single connection pin, basically. So input pins are typically single connection if they are data pins, because they want their data from one place, not like many places, naturally. And output connections are typically multi-connection, so you can hook them into several things. I do actually want, as input pins, I want those filter pins, right? So here we have the UI node for the wave asset node, and it uses a system like this. And this can get a little hairy. So this all has to do with the fact that this node can get resized. Let's actually just drag this off to the side here, and I'm gonna copy paste some things from it. So we have the noise type here. This needs to match the noise type that we have here on the data side. That is the only sort of noise related property there, but we also then have the advanced settings visible just like we had here on this side, so that needs to be represented as well. So get rid of those other ones. And here we have noise node, noise type. Looks like so. And that should be fine. Right, this looks a little complicated maybe. Getting a property out of one of these UI nodes is as simple as returning it, but setting it uses something called setField. This is here in the UI base node. This actually runs like a command on the editor application. And this is so that if you toggle a property or set it, you can then undo and redo that setting of it. So there's a bit of boilerplate that kind of comes in as part of this. And then we want this update size business to be put here. Let's see, we don't have the length and asset ref as we discussed previously, so we can just take those away. And then we have a few different constants here. This is all again just copy pasted from the asset, from the wave asset node. So let's just get everything set up here properly. So we have the type. We don't have these input boxes, wet, room size, damp, and filter width. Those came from the other node that I copy pasted. We do have this this type property. An ST node select enum box. This basically gives us a drop down so that we can select out of these white, pink, brownish, bluish. We don't want to take that away. These go away. We can take them away. But we do want the input pins for the filter connections. So let's just copy over some more stuff from the wave asset node. And yeah, there's a little bit of boilerplate that needs to be handled here before we can actually get to the really interesting noise stuff. Advanced settings visible. That is there. Yeah, I think that's basically it. So what we do here is some of these options, aka pins, they need to be disabled or enabled, and so we actually need to get a reference to them so that we can actually hide and show them. The output option is always there, so this output options add out is just like we don't assign it to anything. But these ones we need to do. And then ST node editor, the library, it has a somewhat weird way of actually sort of pushing things down the side of the node. You had this ST node option empty, and we just do it 5 times here, so we're sort of pushing it down because, let's see if we can actually run this now. I'm hoping we can. If we go here, we can see that these filter pins are down here below this sort of main area in this sort of like darker advanced option area. If we didn't push those empty nodes there, they would actually appear here on this side, kind of overlapping with this waveform here. So that's why we push them down. I think the 5 is probably going to be the correct size, but we'll see. We'll see. And we need to add this button here as well. Not sure if that was actually already copy pasted over from the other one. Doesn't seem to be, but it's pretty easy to do. So we just put it here. So we have less or more. That's the texts that it shows whether or not that those advanced settings are enabled or not. And show up down arrow is the last one. Yes, true value text, false value text, property name. So this takes like the name of this property, and I think this text toggle button actually sets it. Yeah, it just goes in here and gets the property using some reflection stuff, and then just sets the value of that. So advanced settings visible. This will get sort of auto-magically called when someone clicks that button. So we toggle the boolean on and off. Then we call update size. Update size then goes in and shows or hides that, or actually adds and removes those nodes from those pins from the node. So that's basically how we get like those pins to go away or be shown there. All right. Let's see. Actually, I want the output option to be probably... Let's see. So that comes from the other other node. Typically I do the input options first, and then I do the output options. Yeah, and the output option is the same. It's an audio source. So with the input options and output options, they need to match the input pins and output pins. And the names also need to match, so that we know what we're actually hooking up to what. Alrighty then. What else? So here we don't have a waveform as we do in the wave node, wave asset node, but we do have a drop down. I'm not sure this drop down placement is correct. Let's start with something like that, and let's see how. So fixed width is 180. That's maybe a little unnecessarily long or wide, I should say. So let's look at what we had here in the reverb filter. So reverb has 140. Let's use that. Yeah, if this is 140, then that can be 120. That makes sense. Okay. And what else? Typically you have to lay this out and then add one of those nodes into the data and see like, oh, okay, yeah, that thing is sort of not aligned properly, and then you go and fix it. And then finally we have to actually override the rendering of this node. So this actually becomes quite a complicated node. And here again I'm copy pasting some stuff from the wave asset node. So we're overriding onDraw node, which again comes from the ST node editor library. We're not rendering any wave forms, so we can just get rid of the waveform rendering completely. The important part here is this if advanced settings visible. We render that slightly more dark background, slightly darker background there. Text brush probably isn't needed either. Which then makes it look nice and polished. And what else? Maybe that's actually it. Maybe we can try this with the current version and see what we get. So now we have two classes, okay? How do we sort of match them together then? And that is done here in the node mappings. So again, when we load a project, or indeed we just create a new instance of this noise node, what we are actually creating is one of these data noise nodes. So one of these guys that sit in Timbre nodes audio noise node. And then if we load the project back up and the data is loaded, we encounter one of these noise nodes. We need to somehow match that to the UI node, and that can be done here in the node mappings. So this is just a large array, really, of tuples from type to type. So we quite simply just list our new noise node here. So it's called noise node. Here you can see the reverb filter node, the stuff that we worked with last time. And it's UI node to data node. So Timbre editor nodes audio noise node to Timbre nodes audio noise node. And now, if we build this thing, we should actually be able to drag one of these new noise nodes into a flow graph. And it's probably going to look a little broken. Typically they do. So we can do here noise, just drag it here, and you can see, oh, all right. So it's all right. It's a little unnecessarily tall, and of course this white drop down here is outside of the thing, so we need to move that up. And I just have a sort of a standard here of like having one sort of row of things in a node like this occupy 20 pixels. So I think we can sort of fit this into. I think I'm going to leave one empty row up there if I want to actually write a label for this output node. So we probably have like 1 or 2 unnecessary rows. So we need to move this up by like 4 rows and then make the whole thing 2 rows, i.e. 40 pixels lower. That is my guess. So let's see, type box needs to be like, what did I say, 3 rows up. So that would be 1 row, that would be 2 rows, that would be 3 rows. Let's do like incremental fixes to this. And yeah, this is a little manual, and there's no sort of hot updating or anything, which is a little. Oh, I changed the wrong value. That's not good. 120 is completely fine, but it's this one. So it would be. Is it 41 then? Just sort of designing these nodes can be a little annoying. There we go. Right, so it's actually 21. Yeah, 21, and I think we can make it just 1 row lower. So 21, and let's make this. That would be 190, and that would be 92, probably. I hope the. Oh, and then I need to probably. Yeah, I think I need to have 1 less of those empty. Yeah, so the button now needs to be 1 row up, and I need to have one less empty row there, and that's gonna make it look good. So just 4 empty rows, and this guy needs to be at 48. There we go. So now everything is as we want it to be. Right. So now we can create, or at least conceptually, we can create noise. We can attach filters to the noise immediately. This is probably something that I'm going to want to do quite early, and that's why I put in the work now to have this advanced pin area here, because noise by itself isn't really typically useful for much. Like you typically want to sort of modulate it a little bit. You can do a little bit of modulation by changing the playback speed and things like that, but typically you want to do like a low pass or high pass or band pass filter on it or something like that, and then sort of animate those, and that should sound kind of nice. Oh, speaking of, I turned off the music and I didn't put it back on. I think let's have a little bit of background music until we get to the actual part of the stream where we create noise. So that's cool. Okay. We may actually be done with the data part now. So what I will do is actually go here and I'll create a new event, or graph event. Let's call this noise test. So this is my testing project, and the point of it is just to test out new features like this. So let's say we want to play just as the very first basic test of this noise generator. We want to play like 10 seconds of or shall we say 5 seconds of white noise. How do we do that when this noise really has no length? And the way we can do it is quite simply we put a delay and then we end sort of forcefully the event. So we begin the delay, but we also start playing the audio like this. So these things will now sort of start executing in parallel, these two guys. And then after 5 seconds, we finish the event. Now, if we save this and I click play here, we'll get an assert error. Assertion failed. Sprinter type node timbre nodes audio noise node not registered. So that's important. This path here is important, and this is what is called the registration path for the node. So now the editor has everything set up nice and smooth. If we load this back up, we should get the whole thing back, and we can see that it's connected properly and everything. But the runtime still has no idea what the hell a noise node is. So I'm going to copy this path just and move it off to the side. And we need to go into the runtime side. I'm going to go create some files here for us. So let's go to Timbre, include Timbre nodes. I'm going to just take a wave asset node here and call it noise node, and then we go to the source side, wave asset node, and create a noise node here as well. And the last thing we need to do is in the CMake script, we need to actually include those guys. So in Timbre, CMake lists, just have the node headers here. So let's include it right after the reverb filter, noise, and same thing for the CPP side. Like so. And then we can regenerate the CMake project files. Alrighty then. So in the header, we just have a registering function. So let's rename this. This is I copy pasted it from wave asset. It's called register wave asset node. Let's just rename that to noise node. And here is now, this is the important part. This is again one of those registration names. So we'll just take this Timbre nodes audio noise node. So this is the name that Sprinter at export time will export into the data. This is the kind of node that we have now encountered. And you can see that this path here, this Timbre nodes audio noise node, is exactly the same as the data path. Timbre nodes audio noise node. So it's one of these guys. The exported data has no idea about these UI nodes that we had here. It only sees the data. It doesn't know what an editor is, sort of conceptually. And this is the only function that we need to actually call to hook this whole thing into the runtime. So here in the CPP side, again, let's rename these wave asset things just noise. Probably don't need that one. Probably don't need that one either. Filter we might actually need. So here is where we need to specify the input and output pins. And we have the filter ones and we have the out one. We don't have these. Actually, I'll just take them away. Then we have some state. So nodes may or may not have state. If they have properties, such as in this case, the type of noise that we want to generate is a property of the node, then it has state. And you don't necessarily need to create a state struct to hold it. You can just deserialize it from the data every time. But it typically makes sense to just quite possibly faster to do it once and then reuse the thing rather than deserializing it every time you need it, right? So we'll want to have some state. And in this case, we also have state because we have the actual noise generator is going to be some state. Here we have a wave audio source, and this is the actual audio source thing that we use for the wave asset nodes. So we will most likely need to create some sort of equivalent for the noise, like a timbre noise generator or something like that, which is like an audio source. Let's actually go have a look here at this wave audio source class in Timbre. Let's see, it should be somewhere around here. So wave audio source. This basically just wraps a so loud wave or web. So this is where the timbre world meets the so loud world. If you consider it sort of like we have so loud on one side, and then we have timbre, which is sort of sitting on top of so loud. This get SLAS, this means get so loud audio source, and it actually returns just a reference to an audio source. So this comes from the timbre base audio source class. This is sort of like how you hook it into the actual sort of audio playback system. You have a timbre something. So loud doesn't really know how to work with a timbre something. It needs a so loud something, so it calls this get so loud audio source, and then you return the so loud sort of equivalent of that, if that makes sense. And what else? What else do we do here? Like, this is a wave audio source, so naturally somewhat big part of this is just actually we're acquiring the wave asset, and then we're initializing it. I think the init clone actually just copies over a bunch of things here, and it copies over the actual sort of sample data here. And wave assets can obviously, they can be quite large. But we don't have to do any of that. The noise audio source should be comparatively simple, because it's just a noise generator with some initializing data basically. So that should be nice. Get length. I think that's probably not part of audio source, right? No, audio source doesn't expect the length. That's good, because we don't have anything to give it, to be honest. But wave audio sources have length. Anyway, let's go back to the node for now. We create the state. So this is a function that we can hook into the system. Whenever the runtime creates one of these nodes, you can have a function that you hook up to it, which allows you to create the state. If we go back here to the header, we have this register noise node function here, and it is right here. This is it, and this is where we register the pins. We can register a create and destroy state function, and we can register get pin value. And this is very important for one of these nodes that basically provide the system with some data. And this get pin value, I bet if we go, and actually not that one, but this one, again copy pasted from the wave audio wave asset node. We check which pin is it that actually wants data. If it is the out pin, this is where we actually write the address of this audio source that we want to return. Then we have the length and the asset ref pin. We don't actually have those, so we can just take those away. And state update filters, yeah, I think we will actually probably want all of that. We will want to have that boolean there because we have filters. Just that the audio source that we still haven't created that basically. So we need to make that happen. But yeah, the audio source should support filters as we discussed previously. Node property stream here. The wave asset node has the wave asset ID in the property stream. We don't have that. We instead have the noise type as we established previously. So we have this enum here. So instead we need to get that kind of data out of it, right? So let's copy this here. Noise type, white, pink, brownish, bluish, and we'll quite simply just do noise type, and we can get that out using get as uint32, like so. So here we are writing the type of noise that we chose from the drop-down menu to the runtime data at export time, and then here we are reading that back, if that makes sense. I'm thinking this noise type, though, we might want to actually make it so that we can just give this, we can pass this to the Timbre audio source, right? The noise audio source. You just init it with, like, initialize it with a certain type. That kind of makes sense, I feel. Which means that it probably should be defined somewhere else. And that somewhere else is probably in, like, the Timbre header. So here we have a bunch of enums, as you can see. I'm just going to put it here instead. We can do it like an enum class. Enum class, noise type, like so. And now that it's in the timbre.h, both this noise node and the noise audio source, which we will create in just a sec, we'll be able to use it. Like so. So this gives us an error. That's because it's the audio source. Same thing here. Same thing there and there and there. So basically we have the runtime for this node already done, except we just need to create that new audio source. So let's do that next. And I'm just going to go here, and again I'm going to copy paste the wave audio source. I'm going to just rename this Timbre noise audio source. And the same thing for the CPP file. No, it's this one, so noise audio source. And then we need to add it to the CMake lists. I think this should be the last file that we need to create. And actually, as soon as we have this working and hooked up with the runtime node, we should already be able to do like a whole lot actually with noise, assuming that I haven't forgotten anything. So with noise and a filter or two, you can, for example, create like whoosh sound effects quite easily. That should be fun. like so. Yes, reload all. Drink a little bit of water. Right, so let's find this guy here. Timbre audio source, so loud web. I think it's probably just called so loud noise. And then this needs to be noise. And then that needs to be noise. Then we take those guys away. We don't have any asset refs. Sound manager, that probably makes sense to have, so let's keep that around. I'm not 100% sure we actually need that. Yeah, it looks like we actually don't, so let's not have it then. Let's just take that away. So I'm gonna do init type. I'm gonna call it init type. And then let's do like to do add a second init which exposes the blah. What was it called? Set octave scale. So loud functionality. This is then for when or if I add like the advanced noise later on. All right, Timbre Sound Manager. We take that away. We can take both of those away actually. Timbre audio source. I'm hoping this includes Timbre H, which it does. So that's nice. So now we can just do Timbre. Actually, we are already in Timbre, so it's just noise type. Noise type. Like so. Just bring this CPP over to the side. This is nice. This is just so very, very simple. All of those guys go away. You basically only have that noise there. You might even wonder if this is sort of worth actually wrapping in a class like this, but it is actually, because with the filters there's some reasonably complicated logic to actually determine when the filter values for a particular playing voice should be updated. You can see here that it has a method called update for voice. So voice is like it's like an instance of this audio source that gets updated. So it tries to like minimize updates to audio sources if it can. And so that is one important reason why we actually need to wrap this so loud noise inside like an audio source, like a Timbre audio source. Right. So now with the type at hand, we can switch on it. We have white, and that will give us mnoise init. Or was it set type actually? Set type, and it's probably so loud noise white, right? Something like that, and break. Nope, that's not how we do it. Like so. So it was white, it was pink, it was brownish and bluish. It'll be interesting to hear how brownish and bluish sound like. Now when these are all uppercase. Yeah, so this is significantly simpler. I don't think there's really anything to de-initialize here, necessarily. Anything to do? I don't know. We'll figure that out later. Yeah, the noise is an audio source, so we can just return it like this. That probably works. Now I realized that I still call this wave audio source here. It needs to be called noise audio source. like that. The get length we don't want. We don't have it, and we don't want it. Function definition. Okay. Right. Like that. Now it should be happy. Cool. And I'm hoping the interface looks exactly the same, so we can just do that. That looks like it's working. Let's try to build that file, and it works. That's great. Okay, so this should be really sort of like the extent of the basic noise. We initialize it. This get SLAS is the way that we hand it off to the audio playback system. Update for voice just calls down into the base class, so arguably we don't even need to override it here. Let's just take that away. And set filter. What does this do? Right, it just sets it there in the base class as well, and then it sets the filter on the actual noise. That's fine. So just like we have get SLAS, which is get so loud audio source, on the filters we have get SLF, which is get so loud filter. So this returns a so loud filter reference, and this returns a so loud audio source reference. So they're sort of mirrored in the sense. Nice. And now we should be able to go back to the node, noise node. Wave asset audios, wave audio source. Let's instead import the noise audio source. Sound manager, I don't think we need that. Filter one we might need, I guess. So now we can do timbre noise audio source, and we initialize it with init type, and we just pass the noise type that we deserialized out of that stream. Give it to the audio source. That looks good. We do call dinit here. There might be something to do later, especially related to filters. So I'm going to keep that around. We don't need to destroy it because it's allocated using a node state, so it's like using a linear allocator basically. Update filters, you can see all of this, we don't have any errors here anymore because all of these things are now according to the audio source API basically. Take those away. Right. With a little bit of luck, this should now work. There's one more thing that we need to do though, and that is actually call this register noise function, register noise node function, to actually hook this sort of runtime part into the system. And that can be done in timbre node registration. Timbre nodes noise node, and then we just need to call it. So these are all the nodes that can be used from a timbre effect or event. Because we have a bunch of really sort of basic things. We have like the delay node here, for example, which we use in that test event. These are part of the Sprinter runtime library. They're sort of like your average sort of standard library, if you will, in air quotes, for one of these node graphs. You typically want to do, you want to be able to have like an AND or an or a delay or a repeat or a lerp vector, things like this. So they are all registered here. Some of these you can register them with like a specific name if you don't want to use the normal name. And here it looks like I've registered this curve ones with some other names. And then we have the timbre specific ones here at the end. So let's build that. And now that we have this built specifically in release mode, if we go back to the to the tools here and we rebuild this one. Now's the moment of truth. We'll soon see if this noise actually makes some noise. The noise node makes some noise. So now we should be able to open that up and press play, and we should get some white noise. So fair warning if this is really loud. I'm thinking it probably won't be, but let's see. It's about as unpleasant as you can imagine, but we do get noise, so that's nice. Let's try pink noise. And that's already nicer. Brownish. What was the like explanation here for these guys? So brownish noise, increasing weight on deeper octaves. Oh, sorry, increasing weight on deeper octaves. And then bluish noise, decreasing weight on deeper octaves. Or octaves, I don't know. Yeah. But hey, this is cool. I now have noise. Oh, right. Yeah. It ends, and it ends because of this, of course. If we take this away, it won't ever end. It will just keep going and going and going. But that's cool. So now we can do something fun with this, I guess, for some definition of fun. Let's put a filter on it. Save this and do a biquad resonant filter, which allows us to do low pass, high pass, and band pass filters. And let's try what that sounds like. So low pass, you can hear that it's really sort of muddled. If you do a high pass, it's just removing the bass from it. Let me know, by the way, if you can't hear this at all. I do realize that this might not be super audible, but I don't want to like blow out your ears with very nasty noise if I can help it. But yeah, this is kind of interesting. But what is even more interesting is if we animate this filter somehow. So let's put in a curve. Let's put in a curve node here. And I'm thinking we should probably animate with the event time. So let's get the event time like this. If we keep this 5-second length here for this, we can animate either like the wet, which is like how much to apply this filter, or we can animate, well, either one of these guys. Let's begin with the wet one, which goes from 0 to 1. So if the x-axis is now the time, so it goes from 0 to 5, then we need to draw something here. So let's do like, I need to probably scale this somehow. Let's move that to 0 exactly. Then we can, by let's say 2.5, so halfway through the thing, it is at 1, and then again at 5, it is back to 0. I can frame this now, so now it looks like this. So now we should be able to hear this. It should be some kind of whoosh, probably. So that's kind of interesting, I guess. We can do something else with this. Let's do like a let's modulate the frequency instead. So it starts at 500. Let's start it at 0 and then go up to like 3000 or something. Actually, I'm probably gonna just delete that one. Let's frame this again. Let's just delete that guy, and just take this one, move it to 3000, and we can we can just use a Bezier curve for this. So let's try something like that. So it starts, if we have a low pass, this should basically start at silence, right? If we have a low pass filter with the frequency set to 0, and then it just nothing passes, right? And then over time we let more and more through until we reach 3000. I don't know if 3000 is like a sensible thing to have as an upper limit. Let's get rid of the wet. So just keep it at 1 for the whole thing. Let's listen to this. So that's kind of nice. Let's put up the volume a bit. And there's a little bit of clicking. Yeah, I'm not sure what the clicking is. Probably have to look at that at some point. But hey, that's kind of interesting. Let's make it go down again. I think that kind of sounds like it wants to go down again. Let's make it maybe like 8 seconds, and it can end at like 500. Then we'll just tweak this curve a little bit. No. Chill. Oh, Jesus. Yeah, this curve editor is not the best. I should really make it better. Okay. 500. And start to yank this around a little bit. Yeah, this curve editor is actually kind of horrible. But that's a problem for another day. Right, so now we actually don't need to even end it at 10. We can end it at like 15. So it will just stay at this, what was this, 500 after the 10 seconds. Kind of sounds like some sort of wind or something. So that's kind of interesting. What else do we want to do? Maybe we'll put a pitch shift filter on it. That might sound kind of horrible, but let's just mess around with it a little bit. We can call this pitch. Create a parameter here. So pitch is 0, then it's unmodulated. Let's make it go from -2 to 2, and let's yank it a little bit. Right, so it really doesn't change at all. Pitch shifter is probably not the correct thing to really add to one of these. I should expose some more of these filters. But reverb, that this also might sound kind of weird, but let's have a look. And that was already kind of interesting. Hey Matt, yeah, I'm messing around with noise today. So I've been implementing this noise node here, which allows us to create some interesting noises, and now I'm just playing around with it. Modulating it in different ways. Yeah, I don't know what that click is there in the beginning. I probably need to look at that, what that is about. Well, that's kind of interesting. Let's try pink noise. It's much more pleasant to listen to, I think, this pink one. Brownish. Bluish. Yeah, I mean, it is noise. It probably will be super handy to use as a base for all kinds of effects, but with the limited set of filters that I have currently, there's only so much you can actually do. See what kind of filters do we have here in So Loud. So we have backward resonance. That's the one that we're using. We have echo, lo-fi, flanger, DC removal. I do have the wave shaper filter. It is basically used to add distortion. So let's just try just the little one. This might sound kind of nasty. Doesn't sound very bad yet, at least. Yeah, it's starting to sound kind of nasty because it's basically just add distortion. Mostly meant as a voice distortion filter, so it's not very nice. Robotizing reverb. Reverb is the reverb filter that we just had, which made it sound kind of interesting and nice actually. Except for the click in the beginning, that was really, well, that is really unpleasant. So we make it like pink. Room size, I'm like 0.25, something like that. That almost sounds like some sort of magical spell or something, right? Like if we make this like frequency, frick, minimum 100, maximum 4,000, ascending, let's make it 1,000, and descending the same thing. So now we can, let's see, float. Oh, I didn't connect that to the pitch filter, so that was why it didn't. Yeah, I'm just I'm just tired. It's quite late here. Anyway, now if we play this, you can see that we're not hearing anything. That's because the frequency is so low. And it's gonna end very soon. Let's make that like 60. And this sounds kind of interesting. It's almost like some sort of magic spell effect. Right. Let's try that pitch filter one more time. It might sound really bad, but just since we are messing around with this now, so I'm gonna add this as a second one, pitch, and -2 to 2. And just copy this here and set it to pitch, like so, and we'll add that as a third filter. So now we have filters going. Let's see. So frequency, bring in the frequency. and then start messing around with the pitch. Yeah, the pitch does work on the noise, especially after applying the reverb. I think the reverb adds a little bit of sort of some harmonics to it, which actually makes the pitch sort of easier to hear and to actually modulate and to like realize that, okay, yes, this pitch shift actually makes some difference there. If you could split the signal path for the reverb and the signal, you could apply a low pass on the reverb set to around 6K. That may make the verb sound less metallic. Yeah, it is possible. It is possible that is what would happen. I am not sure that So Loud mixing actually allows me to do that, though. But yeah, that is something to look into. Overall, the mixing is something to look into. I haven't actually messed around with that all that much. Basically, what I have currently are these buses. So music, sound effects, and vehicle effects. Well, this is a test project, so this can be just like anything. And you can see here that this is added to one of these. These are sort of like mixing groups, if you will. And you can have buses play other buses, and then those buses play audio sources like noise or wave assets, things like that. But yeah, I'm not saying that it can't be done. Just let's be completely clear here. I'm not saying it can't be done. I'm just saying that I don't know what is possible. You can see here that the it's sort of like this is the idea that you're sort of supposed to use this. So you have some audio, then you have some mixing buses, and then you have the final mix. And it is worth keeping in mind that So Loud is really only sort of designed to be a runtime audio playback library for games. It's not really meant to be. It doesn't try to be like a full DAW level audio library. So some of these things might be a little limited, but again, it's just C++ code. So if there's something that can't be done, then you can typically, with a little effort, you can do it yourself. But yeah, I need to look into the mixing. There's really no sort of mixing deck or anything in Timbre either, for various reasons. I am not very experienced with mixing audio. I'm not really experienced with audio overall, but in particular mixing, it's not something that I'm super experienced with. So that whole side of the audio authoring is not really something that's very well represented here. Yeah, this works. This works. So basically, I think I am done for today. It's getting kind of late here in Finland, and I probably need to go have a look at what the kids are doing. So thanks everyone for hanging out today. This may have felt a little bit rushed. I didn't have that much time to stream today, but I figured this is a somewhat simple thing. Maybe we can get it banged out on stream, and yes, we were able to do that. So now we have noise. I need to look at some of those clicks and bangs and clacks that we can hear there in the mix and figure out why they are there. and probably expose some more filters so that we can really sort of unleash the whole sort of audio landscape that filters allow us to tap into, or not filters, but noise and filters specifically. I'm thinking I might want to use these for some of the more sort of reactive sound effects, like the suspension for the car and things like that are really kind of tricky to actually author wave assets for. Like, yes, you can have some noise that you just load from a wave file, but then it needs to be kind of uniform, and then you mess around with parameters and filters to make it react to the car. But it's even nicer if you could just generate that noise using something like this to begin with. Could be phase issues causing pops, reverb just tends to transient. Yeah, yes, absolutely. I do think that we can hear it even without the reverb, though. Like you can hear some pops there. Might actually be this biquad resonant that causes it, or maybe it's just pitch shift. Yeah, you can hear it with this biquad already. So I wonder if there is something with this filter not being applied for like the first mixing update call or something. That might be the case. Like, it's initially set to 0. What if we keep it at 0 so it doesn't actually rise from that? Yeah, you can even hear some clicks here, even though I'm sort of technically filtering away everything, right, with low pass. Maybe that is something that like So Loud handles in a wonky way. If you filter away everything and just have like a 0 stream, maybe that's something that causes like some issues. But I don't know. It might just be something that I'm doing, that I'm doing something stupid. But yeah, anyway, probably all going into the motor vehicle motor noise at some point. Yeah, maybe that is possible. We do have the other motor noise. This is an older version here in this test project, but this one doesn't actually use any filters currently. Just playback speed curves basically, and then a bunch of different RPMs. But we'll see. Filters do all affect the phase of a signal. Yeah, they do. Well, I guess technically not all of them necessarily do, but most of them do. Yeah, that is true. But yeah, that is for me to figure out. Let's undo some of these removals here. We had a somewhat interesting. Oh, that was a loud pop. It's fun. Alright guys, thanks for hanging out today. I think I will end it here. Now it's up to me to make something interesting with this. But have a nice evening or night or whatever the time is where you're at. And hope to see you in the next one. Do like, subscribe, do all the things as usual. And have a good one.